Hi guys, I just wanted to come on here and record a lesson for tomorrow, Thursday. We were asked by administration to send you some work to do for tomorrow today, just in case any of you lose power or have difficulty getting on tomorrow. So tomorrow's lesson anyway is pretty short, so I'm just going to record it for you. I do have the solutions to last night's homework up here. These were from homework number 40, where you're solving these equations, either exponentials or logarithms. Any of the ones that are decimals, if you rounded them to 4 decimal places, that is fine too. For number 12, that one, if you have 0.5, again, that is the same thing, so that is totally fine. Okay, so the next part in section 6.6 are ones where it's not a log equals a log or a log equals a number, okay? We may have something where we have 2 logs on one side. And in this case, if there are 2 logs, okay, 2 logs on one side, that usually means that we're going to get 2 solutions, okay? So if we get 2 solutions, we most certainly have to check for extraneous solutions, okay? So we've done this before with equations, where you plug into the original and you check to make sure they work. Same dealio here with these, okay? Let's take a look at this first one. Solve log of 2x plus log of x minus 5 equals 2. Notice they're both in base 10 since it's not written, but because I have this addition of 2 logs over here, we need to combine these and make it a single log. So good thing we learned those tricks yesterday to make a single log. Remember, when you're adding logarithms, if we want to put it into a single log, that would change into multiplication. Okay, so on the left, we have log of 2x plus x minus 5. Addition, when we combine it into a single log, turns to multiplication. And on the right, we still have that little old 2. Now these are similar to the ones we did in class today. I need to get these x's out of the logarithm. So I need to do something to each side to make that happen. The base on this logarithm is 10, right? If it's not written, it's 10. So if I take each side and I put a base 10 there, that's going to cancel with log base 10, and I'm left with 2x and x minus 5. On the right-hand side, I have 10 squared, which is 100. Now I'm going to solve this equation. So usually what happens with these is you're going to get 2 solutions. In other words, you'll see a quadratic happening here. All right, we know with quadratics, if there's a bx term, which there is here, we gather everything on the left. All right, so the first thing we do here is we're going to have to factor this trinomial. I do see I have a nice little GCF there of 2. So I'm going to take that out of everything first. I have a nice trinomial, a equals 1. 2 numbers that multiply to negative 50 add to negative 10, or add to negative 5, I'm sorry, negative 10, positive 5. Now we're going to set those pieces equal to 0. We're going to get 2 potential solutions. It's 2 because he doesn't have an x on him is kind of, we don't need him at all when we're solving. We're going to set each of those equal to 0. Our 2 potential solutions are x equals 10 and x equals negative 5. Don't circle them yet because we need to double check them. Okay, where do we double check these? The original problem, the one listed on the page, typed on the page. So the first one that I want to check is x equals 10. So I'm going to go up to the top there. I'm going to type in 10 every time I see an X. This is log of 2, log of 20 plus log of 5. And the key here, so make sure you realize this, when you're checking, do not combine these at all. Don't put them together. Okay, you're literally just looking into the very beginning, and we're seeing if this is a true statement. Now, these are both in log base 10. Okay, so I can figure out what these two numbers are on my calculator, and I'm going to see if the sum of them is equal to 2. All right, so I'm going to grab my calculator. It's in base 10, so I don't have to do change of base. I'm just going to simply do log of 20. Okay, enter. Weird decimal, and I'm going to add log of 5. And I'm not going to round them because I want to be pretty on point. And I don't know if you can see me at all on this screen, but you do get 2 exactly. Okay, so you find the decimal in your calculator, you find the decimal in your calculator, you add them together, it is equal to 2. So I can say that x equals 10 is a true solution. Now let's do our check on negative 5. Again, you're plugging into the very beginning. So I have log of negative 10 equals log of negative 10. Oop, not equals. That should be a plus sign. So sorry. Plus log of negative 10 equals 2. Remember, do not put these logs together. You're testing it out in the original. Now, here's the deal. We haven't really talked about this, but if you try to do log of a negative on your calculator, you get an error, and it says non-real answers. That's because that's impossible. When you're finding a logarithm, when you're finding the solution to it, you're finding something to a power, okay, is equal to this value. Well, all of our bases that we've been talking about, all right, have been positive numbers. So if we have a positive base, and if we have some sort of positive or negative number over here, are we ever going to get a negative as our solution? No. Okay, so it cannot be a negative. So the instant that you see that you're doing the log of a negative, you say, nope. So that would mean that x equals negative 5 is what we call extraneous. And this is what you would list as your solution set. Okay? Okay, so let's just try one more. And again, some of the problems that you are going to have for homework are going to be ones that you can simply solve. It's just going to have one log on one side. So you just quickly do the exponential on each side, right? Like we learned in class. But if you have 2 logs, since this is new, I want to make sure that we're good. So I notice I have 2 logs on the left. It's addition of logs. So in order to make that a single logarithm, I'm going to multiply these 2 pieces together to make it one single log, just like we did in the previous problem. Now, in order to get these x's out of the logarithm, I need to do a base of each side that will be the inverse of doing log base 6, which is doing base 6. So if I do base 6 on that side, I get 6x. X minus 1 equals 6 squared, which is 36. Distribute. 6x squared minus 6x equals 36. Just like the last problem, you're going to have a quadratic. So bring everything over to one side. Ooh, GCF again. Cool. GCF of 6. That's awesome. All right, so 6, cool. We don't really need you here because you're just a plain old number. 2 numbers that multiply to negative 6 and add to 1. Careful with your 3's and 2's here. Negative 3, positive 2 is the pair that works. When I said each of those equal to 0, and again, this 6 I don't really need. I can ignore him because he doesn't have an x on there. My potential solutions are 3 and negative 2. So I'm going to try them out. Don't circle them yet. We're going to do our check for x equals 3 first. You plug into the very original problem on the page. Log base 6 of 6 times 3 plus log base 6 of 3 minus 1. And we're seeing if that is equal to 1. Log base 6 of 18 plus log base 6 of 2. Again, do not combine these. You're testing with the very original on the page. Oh, geez, when I go to figure out what these numbers are, they're not in base 10. So no problem. We can use our change of base theorem, which means log 18 over log 6. I'll figure out what that number is. And then log of 2 over log 6. And I'll see when I add those two gross decimals together if I get about 2. So I'm going to do the first one. We're going to do log of 18 divided by log of 6. And since this is a two-stepper, I will write the decimal down for it. Okay, it's about that. I'm rounding. And then for the next one, we're going to do log of 2 divided by log of 6. And that is about 0.3869. So let's see when we add those two numbers if we get to 2. So I take that 1.6131 plus 0.3869, right on the money. That means that x equals 3 is a solution. All right, now don't always assume the -1 is going to be extraneous. Sometimes when you plug it in, it makes a logarithm that's positive, so you're good to go. So let's do our check. I'm going to do it out up here so I don't run out of room. For x equals -2. Now, I'm already seeing something bad happen here. And maybe you see it also. I'm already seeing a log of a negative happening. And the instant I see that, the moment I see that I'm going to have to do a log of a negative here actually twice, no. I would just say I can't do that because I can't take the log of a negative. And even if you try, it will give you an error on your calculator. So because of that, I'm going to have to say that x equals -2 is an extraneous solution. I needed him to get my real one. Okay, I needed him to get my real one, but he's extraneous. Okay, so homework number 41, there's some odd questions in there. So the answers are in the back of the book so that you can double check, which kind of works out nicely here. 25 to 32 all, however, you're skipping number 31 in that set. All right, so let me just double check here like I always do to make sure I need to tell you anything, and then I'll let you guys go. So let's see, 338, 7. Okay, 7 to 15 odd are just in a continuation of the problems that we have already talked about. Okay, so 7 through 15 odd are ones where you're trying to get a common base. Okay, and then if you get a common base, you can set the exponents equal. There is one, and this is number 13. Nope, not number 13. Number 15. The last one of that set. It says 3e to the 4x plus 9 equals 15. You're going to get your e to the 4x alone. So I'm just going to start this one for you. Divide by 3. Now for this one, usually we do a logarithm of each side. But because this is an e, we're going to do the opposite of e, which is ln. Okay, ln. So you're going to do the ln of 2 in your calculator and then divide that by 4. Okay, 25 to 32 all are similar to the ones that we did in class today. And some of those have 2 logs on each side. If it's a single log equals a number, you are just going to do an exponential of each side, meaning use a base for each side. If it's 2 logs equals a number, you're going to combine these and then solve, and then do an exponential. So it's really just one more step today. It's a continuation of our lesson today, which is Wednesday. Okay. So I will post on Google Classroom. I'm going to post this up today so that you guys have it. It was kind of I just put this together really quickly when we found out that we should probably teach asynchronous tomorrow, meaning post something up, have you guys work on it, ask questions if you need to, just in case we run into the situation where you guys are losing power and can't access things. All right. I hope you have a great day. Enjoy the snow. Help out your family. Okay. And have fun. Bye. Bye. You want to say bye? Yeah. Okay. Come say bye quick. Say have a good snow day.
Have a good snow day.